Hi guys, hope you all are doing good. So in the previous videos we have learned creation of linked list, traverser, insertion and deletion. So in this today's lecture we will learn another important operation, that is searching in linked list. So let us understand it in a simple way. So in the step-by-step methods. So without any delay, let's begin our today's lecture. Suppose we have a linked list. Suppose we have linked list 10, 20, 30, 40 and the null value. So this is our linked list initially. So now somebody asks one question, that is 30 present in the linked list? So in the given linked list, whether 30 is present or not, we need to check. So 10 is not equal to 30, so we should ignore this element. So 20 is not equal to 30, we should also ignore this element. So 30 equal to 30, so we have successfully found the element 30 in our linked list. So it was found in the third position. So how can we find it actually? So this is the process called searching. So think about a classroom. Let me give a real life example. Suppose we have a classroom. A teacher wants to find a student named Jack. So the teacher check one by one at a time. So she or he gonna checks the every student one by one. So then she or he can get the name of, he or she get the student name with the name of Jack. So the teacher will gonna check row by row and column by column until Jack is found. So this is exactly linked list searching works exactly like that. So in the same way linked list is gonna work. So let us build the logic. So we start from the first node. So we are going to start from the first node, and then we're going to check every node one by one. If data matches, we are going to stop. Otherwise, we are going to move to the next node. So we are going to move next node until we get the. In this example, we are going to stop here because our example is 30 now. So we are going to stop at this here. So this is the last stop. So 30 is successfully found. So let me write in the steps. So in the step 1, so we are going to create a temporary pointer. So we are going to create a temporary pointer. So struct node start temp. So this is a temporary pointer. So initially it is equal to head. So why it is initially equal to head? So because temp starts from the first node, that's why. So in the second step, we need to store the value to search. So for example, let us take example int key. So let the variable be key equal to 30. So 30 is the required element to found in the linked list. So on the third step, we need a loop. So we use for loop. We use while loop here. So while loop. So while temp equal temp is not equal to null. So temp is not equal to null. So we need to have a condition. So we are going to check the condition that if temp data if temp data equal to key, what one we need to print? So we need to print if temp data equal to key, we are going to print element found. So we are going to print element found. So we need to write element found. So after writing this line, we are going to break. So we need to break the statement here. So we are going to break here. So we are going to upgrade the temp. So temp equal to temp next. So we have written the code. So we are closing this while. So let us understand it one by one. So let me give an example. Suppose first node. So what's the first node? First node is 10. So is 10 equal to 30? No. So now we are moving to the next node. So next node 20. Is 20 equal to 30? No. We are moving to next node. So third node 30. Is 30 equal to 30? Yes. So searching stops. So searching successfully completed. So this is how searching in English work. So now let us improve the program. What if we also want the position? So if we are successfully find the element 30, but we need position also. So for that we need to create a counter. So for that we need to create a counter. So that is int, suppose int position. So int position is initially 1. So every time we move forward, position gonna increment. So position will be incremented. So position plus plus. So this is incremented. When element is found, we are going to print its position. So we are printing, so printf, we are going to print the element found at position. So we are going to print position percentile d. So percentile d variable for position. So we are going to print the position of the element in the linked list. So let me take a previous example. Suppose we have the linked list. Let me write again: 10, 20, 30, 40. So this is a linked list. So we need to search 30. So position 1. So position 1 is 10. At position 2, it is 20. And at position 3, it is 30. So we are going to stop the search here because we have found successfully our element. So it's gonna print found at position 30. So found at position 30. So this is all about the searching in a linked list with the position also. So let us see the complete C code for searching an element and the find the position. So I have all written the C code here. So let me explain it one by one. So this is our C code. These two header files are important in every linked list program. So this is struct. We have created a struct node with int data struct node hashtag next. I mean star next. So in the main function, we are allocated some we allocated some nodes. So head node, second node, third node. So in this case, we have added fourth node also, and we allocated the dynamic memory for all four nodes. So we allocated dynamic memory using malloc function. So we have stored the value. So for head we have stored 10, and second node is 20, and third node is 30, and fourth node is 40. So including we are updated the next value. So next equal to null, 4 next equal to null. So that means it concludes that 40 is the last element. So so our aim is to find the element 30. So initial int position is 1. So we are declared a struct node temp equal to head initially. So we have written the condition here while temp is not equal to 0. If temp data is equal to key, we are going to find that position percentile d position. So in this scenario, 10, 20, 30, 40. So 30 is the at the third position. I think 30 is the third position. So it need to print found that position third. So and we are updating that temp value. So temp equal to temp next, and we are incrementing the position. So for example, if there is no element, so that means it's gonna print the element not found. So we are returning the 0. So the final output will be found at position 30. So see, this is the C code for searching for linked list. So this is all about the searching in a linked list. So let us tell something. What if the element does not exist? So for example, let me write in the previous page. Suppose if an element is not present, suppose we have the linked list 10, 20, 30, 40. Suppose I need to search for 100. We check all nodes. 100 is not found. So then it gonna print element not found. So in this case, element is not found. So element is, let me move to the next page. So now this line will gonna print. So in the given linked list, 100 is not present, so element is not found, it's gonna print. So element is not found. So let me ask some questions. Why is lower in linked list compared to arrays? In this question, why is searching slower in linked list and compared to arrays? So in this both linked list and arrays, why searching process is very slow? So it because linked list does not support direct access. So linked list cannot support direct access because if we want to search an element, we need to traverse an entire linked list. Suppose in the scenario of array, we can check by its index value in the array. So that's the main advantage of array. In linked list, it takes lower process to access any element. In the arrays, it takes some low time because array has index. So we must need to check every node in the linked list. So the second question is, what is the time complexity of searching an element in a linked list? So in this scenario, we use the while loop. So we are checking every node. Automatically, the time complexity will be, yes, you guessed it correctly, it will be big of n. So this is the time complexity for searching for linked list. So why? because in the worst case we may visit every node. That's why time complexity is big often. So next question, when is searching very fast? So in this scenario, I mean in the searching of a linked list, when will be the searching will be fast? Obviously when an element will be in the first node, it gonna take less time, so it will be fast access, fast searching when an element present in the head. So this is why where searching will be very fast when the element is in the first node. So this is all about the searching in a linked list. Let me revise it quickly. So we have started, first we need to start from node, we need to check every data. If data is matched, I mean if data is found, we need to stop, otherwise we move to the next node, continue until the null value. So we have successfully seen the searching in a linked list. So in the next video, we will learn insertion at any position in linked list in C, one of the most important interview and exam topics. So thanks for watching. Like the video, share with your friends, subscribe to our channel. So see you guys in the next video. Thanks for watching.